We moved from our study of probability to limits, and limits is really our first introduction into calculus. What a limit is it talks about a function's value. As x approaches one specific value, the question is, what does y approach? That's the whole concept behind limits. Now, notation for this, when we say as x approaches one value, what does y approach, is the following. The limit of some function, f of x, as x approaches some number is equal to what value? And once again, this is our y value right here. So if we look at a graph and we talk about limits of a continuous function, we have a linear function right here that's continuous, meaning there's no breaks or asymptotes or holes in it. And we ask, well, what's the limit of this function, of this line, as x goes to 2? Well, here's the x value of 2. And we want to know, what is y approaching as x gets very close to 2? So, and we want to know, is it getting close to the same number from both sides? So as I move close to 2 from this left side, and I move close to 2 from this right side, does y approach the same number? And if it does, then we say, well, y is getting very close to this number right here. And if we look at our graph, that looks like it's relatively close to the value of 1. Let's look at another example. It asks, as x gets close to 1, what does y get close to? Once again, here's the value of 1, and as x is getting close to 1, from either side, we see that the y value is getting closer and closer to 0. Whereas, if we talk about getting closer and closer to 0 for x, then y gets very close to -1. It's pretty easily identifiable if you're looking at a graph. Now, when we have point discontinuity, in other words, if we have a hole in our graph, we still look at the same concept in relatively the same way. We're going really close to 2, which is right here for x. We want to know what y is getting close to. Now, limits talk about, as x gets close to one number, what does y get close to, not what is the y value. So again, as we approach 2 from this side, being the left side, and approach 2 from the right side, what is our y value getting close to? And it's getting close to the value at this hole. And the value at that hole is actually 2. Now, when we ask what is the value when x is equal to 2 of the function, the actual value at x equals 2 of the function is equal to 4. So you can see that the limit and the function's actual value can be different. So here's another picture of a giant function. We've got some holes. Looks like we've got an asymptote here, and we want to answer these 3 questions. What's the limit as x approaches -2 of the function? So again, as x gets closer to -2 from both sides, what is our y value approaching? It appears that it's approaching this hole right here, and that's a y value of 1. As I get close to 2 from both the left and the right, that means I'm getting close to 2 this way and close to 2 this way for x. What does y get close to? Well, it appears to be getting close to this point here, which again is 1. If I get close to -1, let's do this in a different color. We get close to -1 from this side and close to -1 from this side. You'll notice that these red arrows are approaching 2 different values. Because they approach 2 different values, we say this has no limit. We must approach the same y value from both sides of the x's in order to have a limit. Here's another problem. It would start off as a piecewise, and you actually have to graph it. I've put the graph below here so you can identify it. And then they'll ask you 3 questions. But again, part of the trick is going to be actually graphing the piecewise function. We've gone over that before, so I'm not really going to do it again, but you can match these two up. It asks, as x gets close to -2, what is the limit? And you'll see, get close to -2 from the left, get close to -2 from the right. Even though there's no defined value because we have an open circle here, we can say that this is appearing to be close to pretty much 5. That's what it looks like. As I get close to 1 from either side, x gets close to 1 from this side, x gets close to 1 from that side, we see the function approaches 2. As we get close to 3 from either side, close to 3 from this side, close to 3 from this side, once again we notice that our y values are approaching 2 different numbers, so there's no limit here as well. Now we're going to actually use a calculator to find the limit of the function. So you'll see what I've done is I've plugged the function into the calculator, making sure I have my entire numerator in parentheses as well as my entire denominator in parentheses, and then I'd go ahead and graph it. And you'll see here that as I get close to 1 from one side and I get close to 1 from another side, it's going to be really hard to tell what my value is. So now what I'm going to do is go to my table. And I find the best way to do this also is to make sure we put our table set, so I'm going to go second and window, so that our variables are not automatic. They ask us, what value do I want to put in? So now we'll head over to table. And in table I've already got some numbers in there, so I'm going to clear these out. And what I want to do is I want to find out what happens when I'm close to 1. Not at 1, but close to 1. And how close am I talking? Is it good enough to be at 0 and 1? Well, you'll see if I plug in 0, I get an error on this function. So it's not going to be defined when x is equal to 0. So just for sake of argument, when we talk about getting close to 1, we're talking about really close, infinitesimally close. So if I get close being 0.9999, I'm pretty darn close to 1. And figure out what kind of value I get there. And you'll see that when I'm at 0.9999, I'm at -8.003-ish. Now if I get close on the other side, I'm talking about, a 1/1000th or 1/10,000th away. So if I look at 1.0001, that's pretty close to 1 as well. Plug that in, and you'll see that in both cases I'm about 3/1000ths away from -8. So we're going to assume that my limit then for this function is equal to roughly -8. And in this next example, you'll see that we have a rational function and we're trying to find the limit when x goes to -3. But you look at this rational function and you say, well, hey, look at the denominator. The denominator is actually going to factor into x plus 3, x minus 3. And then if we take a look at the numerator, this would indicate that when we plug in -3, we're going to get an asymptote. But if you take a look at the numerator also factors into x minus 11 and x plus 3. And that's going to reduce out, which creates a hole. So now, if we take a look at this on a calculator, you'll see the following. I've plugged in the function so that my numerator's in parentheses and my denominator's in parentheses, pre-factoring. When we graph it, we notice that indeed there's an asymptote, but only an asymptote at -3. If I go to my table from here and I plug in a value of -3, we should get an undefined answer. Let me clear these out first so we can just look at one thing. So if I plug in -3, I better get an undefined answer because that's where I get a hole, and I do. So now what I want to do is go very close to -3 at either side. So that's at -2.99. And I'll throw another 9 in there just for the fun of it. And I get close to 2.336. And then if I get close to the -3 from the other side, that's -3.001. And once again, I'm very, very close to 2.333. So we would state that our value in this case is 2.333. Now we can also use this calculator method to find limits of trig functions. So once again, you'll notice I've plugged in the function such that my numerator is all in parentheses. My denominator is a singular term, so I don't have to worry about that being in parentheses. And then because we're taking and combining a linear and a trigonometric function, I'm going to put my mode, make sure that's in radian value. For my window, since I'm talking about cosine values, I'm going to make my window for y's rather small. I'll make that go between -2 and 2. Make our x's go from -10 to 10. When I graph it, notice I get a function that looks like this. It appears that we have a value at 0, but we know that if we plug 0 into this function, it should be undefined. And we can check that by looking at our table and plugging in 0. Once again, let's clear some of these out. Let's plug in 0, and we should get an undefined answer. And we actually do. So now I'm going to get very close to 0 from either side, so that's at 0.001. See what kind of value I get out. And it's looking like it's getting close to 0. And if we go -0.001, again, we get close to 0. That's in scientific notation. So we're going to say our limit as we get very close to 0 is 0 in this case. And once again, looking at that graph, you'll see that it does get very close to 0 from either side, even though we know if we plug in 0, our answer is undefined. And that's the whole concept of a limit. So write your lesson summary, fill out your MyMathLab, and we'll talk more about this tomorrow.